Good morning. Good morning to my year 9 friends. Today I'm going to share about the atom. Okay, so you may find some colorful notes from our different colorful notes, but today I'm not using that. Okay, I'll do some summarize. Okay, of the structure of the atoms. Okay, the structure of the atoms. Of atom. So shall I put the there in front? Yes. The idea of atom actually is come from the Greek. Come from the Greek. Okay. This is the first one of saying the atom is from this friend, our friend. Democritus, as early as so. You think that when you cut something, for example, if this is a piece of gold, if I cut half, this half is still a gold. Can you see? If I further cut half, this one will still a gold. If I further cut into half, this one will still become a gold. If I cut off some more, this is still a gold. If I cut half, it will be still a gold. If I cut half, it will be still a gold. If I cut half, it's still a gold. Until very small thing, okay, this item, okay? When I enlarge this item, zoom, 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 okay, become an item. I cannot further cut anymore. If I cut anymore, then there's no gold already. But this is very simple idea, and this is the original idea of this, but nobody can say yes or no, right? Okay, until later date, okay? When Anthony, okay, another color. Okay, and then later we have Mr. Anthony. But this is, I think, 2,000 years later. 2,000 years later. Together with his wife. And later, followed by okay, and then they discovered a copper carbonate. Okay, one, okay, one color of this. But actually, when you cut, it's not, no, it's not. For one thing, okay, for example, a copper carbonate, it's like, even though you think this is one thing, you may have copper, carbon, and oxide to form a copper carbonate. So if you cut here, okay, then they can find, oh, actually they are two different things. However, it's true, still it's true that when you try to cut this, the copper into half, okay, into a very small part, it's still copper, okay. So this is the idea of the Joseph. And then not only that, he found the weight and the proportion of that. Okay, then we come to the within the same time or a few years later, actually, we have, this is the famous one, huh? The Dalton Theory. Okay, the Dalton Theory is this is an Englishman, okay, who studied gas and formed his investigation on the becoming of the carbon and oxygen in produced two gas. The first of them seemed to be made from one particle of carbon joining one particle of oxygen, and in the second gas, it seems that one particle of carbon joined with two particles of oxygen. From his own observation, such as this, and from reading about the work of our Mr. Lavoisier, okay, and he do a lot of reading, and also the props, okay. So he put his theory together, the atomic theory. Okay, so he summarized. Number one, this is a very important thing. All metals is composed of tiny particles, and he call it atoms. Okay. Second, follow these two. Okay. Atoms cannot be divided up into smaller particles and cannot be destroyed. Number three, atom of an element, which is same element, all have the same mass and properties. Number four, the atoms of different elements have different masses and different properties. Okay, last one. Atoms combine in simple whole number. Okay, maybe here, whole number when they form compounds. Okay, this is the whole idea of Dalton. Okay, later in our history. Okay, and then we come to the books. Then this is a book I borrowed from the my friends. No? Okay. So it's a books of the sun. So I think I use this book for the further explanation. Okay. So after that, somebody thinks that, oh, the atom is not only atom, but atom itself must be have something else. Okay. So the scientists now discover that atom is made out of even smaller particles. Huh? Okay. And then they are the proton, neutron, and electron. Okay. So these particles are arranged in the similar way of in every atom, and they found that the proton and the neutron are grouped closely in the center of the atom. They call it a nucleus, okay, nucleus, or sometimes the word used is in. If you want to describe something to become an adjective, the word will be the nucleon. Nucleon, okay. So this nucleus is not nucleus of the cell. Okay, yes, it's true. Okay. So here is a nucleus, and then we have an orbit, a pathway, an orbit, a shell for the neutron, okay, to describe neutron traveling. But actually, the neutron is not following this way. Okay, they can move in other way as well. But this is just an illustration for you to know. And we may use for this book, they are using the proton red color, neutron blue color. So for this atom, we have 2 proton, 2 neutron. Okay, and then we have the 2 electron out there. And in between here, can you see the electron is moving in within this region? So, and this is so-called the empty space. Why? Because if we wave them together, if the red color is 1 gram, the blue color is 1 gram, but this one is 1 of 1008. Okay. So we have 3 things. Okay. Proton and neutron have much more mass than the electron. Yes, actually it's 1,800 more than electron. Okay, in fact, we can call it electron have almost no mass as compared to the proton and neutron. So proton have the positive charge. Yes, one thing you need to know that proton is a positive charge, electron is a negative charge. Origin they carry charge, and the neutron has no electrical charge. Okay. And there is a lot of empty space, the part of the electron. So this one is like we draw this way. It's not so true. Actually, if this is a nucleus so small, okay, you can see the dot is so small. But actually, we may take up such a large space because the electron may move this way. Can you see the electron? The electron can move. This electron, but this electron is like, you know how they move. So all here is empty space. But the nucleus is only take up very small part of the whole atoms. Okay. Okay. So the question is, which particle in the atom has a positive charge? Yes, proton. Which of the 3 particles make up of an atom has the smallest mass? Electron. Which particle make up the nucleus of the electron? No, this is wrong. It's a neutron and proton. Yes, this my friend's answered wrongly, right? Okay. The size of the negative charge of an electron is exactly the same size of the positive charge in the proton. What is the overall charge of a helium? Shows in the diagram. So if this is 2 positive, and then you have the 2 negative, so 2 positive and 2 negative, so they end up is no charge, which is neutral, no charge. Okay. How did scientists find out? Okay, let's start following the story. Now we come to the 1980s, when the British scientist J.J. Thomson discovering the electron. Yes, this is the person who find out actually inside atom we have the electron. So one of the Thomson research student original came from New Zealand. His name is Ernest Rutherford. Okay, and then this Rutherford discovered proton and in the 1909, and the nucleus in 1911. Okay, Rutherford, the most famous is the gold foil one. Okay, this is a very famous experiment. Okay, in this experiment, Rutherford fired a fast-moving particle smaller than an atom. Okay, so this one, you fire some of the particle now, which is smaller than an atom. Okay, if this is atom so big, so small than atom means this is very small. Can you see? Oh, this is very small. Or maybe this is very small. So if I'm using this particle very small, I want to pass through this one, because this is all empty space. Surely I can pass through this atom, right? But if I just nice to hit the nucleus, then I will bounce back. Okay. So when he shoot the particle, the small particle, is supposed that can pass through the thing. Okay. Only a few of this particle was deflected, which is a changing direction. Deflected means that the direction was changed. This let the Rutherford have the idea of that. Actually, the gold atom must be mostly empty space with their particle packed in the dense nucleus in the center. This helped to move forward the model of atom we use today. Okay, so then you think that why? When I hit only when I hit to the nucleus, they are bounced back or deflected, but all the other places we can pass through, So then you think that there must be a nucleus which is very dense here, but the other place, the electron or anything is just a very less density. And actually, I think if everything particle he shot out can pass through the paper, it means there's nothing here, empty. So this is a very famous experiment. Okay, in another drawing of this experiment is look at this. Let me show you. Because sometimes in your exam, they may not coming out with the same as a book. So if you are not knowing about how to draw, how the different way of the apparatus, then you may not understand that. Okay, this should be the one. This is gold foil, which is very thin, about maybe 1 layer thin. Okay, so I have the source of light. Okay, not light, source of particle. Okay, it's light actually. Look at lights. So I have the sensor here. So I have the source of this particle. We call it the alpha particle. So when I shoot one, this one can go through. So it just goes through. Then I can record this one. If I slightly next to this, then suddenly I hit something about the nucleus, then it will bounce away. Next one, if I really hit on the nucleus, surely I will bounce back. So from here, this detector, they can detect direction, but actually most 99% of the ray come out, it will pass through. So when I shoot out 1,000, 999 will be here. If I shoot out 100,000, maybe 990,000 is there, but some are deflected. Okay, some. So now come to the particle we have today. Let's just look at this. Okay, and then another famous person is this James Chadwick. Worked together with Rutherford and Thomson, and he found a neutron. So now we have neutron, now we have electron, and now we have proton. Can you see how scientists found out the thing? So the story of this man shows how scientists all over the world work together and develop their idea. each scientist built on the discovery of others. This scientist won Nobel Prize for his work, their works. Their experiment in idea have helped us to understand the structure of the atom. There is still a lot that we do not know about atoms and about this world. Scientists continue to work to improve our understanding of the structure of the atom. For example, scientists all over the world are using this Large Hadron Collider in Switzerland to further understand the structure of the matter. If you go to the internet or in the library to look for this tunnel of the Large Hadron Collider, this is a very big, across the country. Okay, and it's a very, very large circle, okay, and allow to see how fast the subparticles such as neutron, they can travel. Okay, next one. Then we shall go to our first 20 element. Now, this is according to your syllabus. We need to learn about first 20 element. So you may have downloaded this periodic table. So we have different type of the element here. So this is so-called periodic table. The very first thing, you have two number, a smaller number on the top and a big number on the bottom. Okay, on the top one we call it atomic number, which is the number of proton. You can also call them the proton. That means if you count from that element, one shows that there is one proton in hydrogen. Two shows that there is two proton in helium. And if three, it means that there is three proton in the lithium. Okay, so you can see a number from 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, just like the idea we have learned. Every different element, they have different proton, right? Yes. And they increase one by one. And then next one, the below one is the mass number. Because the mass number, it means that it's not only the proton. Sometimes it may have proton and neutron together. So can you see this beryllium? That means you have 4 and 9. That means this 9 is the number total of the proton plus the neutron. Since the proton is 4, so the neutron must be 5. Can you see? Just do the subtraction will do. Okay. So these are the first 20 elements. We have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Okay. So an atom usually following that's how the drawing. Okay. If you have the 4 proton, you should have the 4 electron that's surrounding you, right? Okay. So there will be no overall charge. No overall charge. Okay. So let's look at this phosphorus. We have 15 protons, and then the total mass is 31. Because the mass is a proton and neutron, so the proton is 15. So the neutron after minus is the 16. Okay. So I have 16 neutron, I have 15 proton, and also 15 electron if this is an atom. Okay, now we need to learn about the arrangement of the electronic cell. Okay, this is the first cell, second cell, third cell. Okay, so according to this one, okay, so this is a Niels Bohr. Niels Bohr is awarded a Nobel Prize, and he tried to teach us that using the cell so that you can better understanding of the chemistry reaction of the element. So this line of pathway is called a shell. Okay, so this shell means that the capacity of the atom holding the electron. Okay, so we have if this is hydrogen, And then we know that there's one proton and then we have one electron. Usually we can draw it as a cross, or if you like more, you can write an E here. Okay, depends. Okay, so and we have another one, helium. Second one is helium. So you have proton, proton. So you need to have two electron, right? So you need to have two electron, electron, electron. Okay. So when I have lithium, so I have three proton. Okay, this is 3 and 7. This is 2 and 4. This is 1 and 1. 3 and 7 means that, okay, the first cell only can carry, the first cell only can carry 2 electrons. So yeah, if I have 3 later, what should I do? But before that, I need to, okay, wait, this is not only the proton, but you have another 2 neutron, right? So you have 2 neutrons. I forget about neutron already. So inside that, I have 3p and how many neutron? 7 minus 3, so it's 4. 4 neutron, and the outer shell there, I have this one cell only have carry 2e. So I need 3, so I need to draw another one. The first cell, also as suggested by our Neil board, is 2, the maximum, and we have later the fifth one. No, the fourth one. For beryllium 9, it means that I have 4p. 9 minus 4, I have 5n, and the outer one I have 4, so I need to draw the first cell, E. Second cell, 1, 2, 3, 4. Okay, so you are using this way, okay. And now I need to tell you something. When this is the nucleus. Let me draw in blue. The first cell can take 2. The second one can take 8. The third one can take 8. And the fourth one can take 8 and above, but for the purpose of learning up to the 20. So this is 2. So we can draw 8, 2, 2, 8. Okay, 8 to 2 means what? It means that you can draw it as 8, 2, 2, 8, 8, 2, or you can say 2 plus 8 plus 8 plus 2, or you can use also 2.8.8.2. Any way of writing is okay, no worry. Okay, so next week we will be talking about how actually who did actually arrange after this 2882, who actually helped us to make it the periodic table. Okay, this is for next week. But before next week, I was trying to show you a table. Okay, a table. So we have 4. This one have 4. Okay. So we have the title here. We call it the subparticle, which is smaller than the atom. So we have, just now I'm using the blue for proton. And then we have the neutron. And then I have the electron, right? So when I talk about charge, Proton carry a positive charge. Neutron carry, this is neutral. And then this is negative. Second, when we talk about the mass number. So if the proton carry 1 weight, the neutron will carry also 1. But the electron is about 1 of 1836. Okay, you can say 1800 or you can say 1840. It's okay. You can round out it, but it's already that it's considered very, very small. And then where is their location? The proton is in the nucleus. Then neutron also in the nucleus. And this is on the shell. Okay. This is Mr. Henry Clement. Okay. Thank you for joining me. And any full color notes, you may always have a look with our dear friend colorful note. Thank you very much. This is for today's lesson. Hope you enjoyed today's short lesson. Thank you. Bye.